will see as to how to get started with Arduino and how we can virtually program.
Hello.
Yes.
Sir, are you able to hear me?
Yes.
Okay, so welcome back, sir. And uh, session is all to you. Over to you, sir, for
Okay.
thanks.
Thank you.
Okay.
So in this session, we will see how to get started with this whole Arduino. I will not go into very much details about anything. I'm just going to run you through the entire process of how you can begin with the entire platform itself. So this is the IDE, Integrated Development Environment, as we call it. This is more or less the software that we utilize to program the Arduino. Okay, so where it is available, you can go to the Arduino website, and from here, uh, you can basically download the software from this website for free. You go to software, you go to downloads, and here it is available. Download the Arduino IDE. Okay, you can download it as per your requirement for Linux, Mac, or Windows. Okay, so once you have downloaded it, you need to install it, and once you install it, here is the IDE. Okay, so it is similar to the C++ programming tools that we use either for Python or for Java. It is kind of similar. Okay, so the best thing is that it comes with few examples, preloaded examples. See, in different categories there are different examples. For basic, in basic category, like a blinking of LED. These are basic examples. I will show you how to run some of these basic examples on an Arduino board. Okay, so in this IDE, there is no simulation, or you cannot see how the program will work. Whatever code you write, let's open up a code. Blink. This is the most basic code that is available. Okay, so whenever you open up a code, uh, this is from here void setup till the end. This is the code portion. This code will run on the Arduino. Unlike what you have, a lot of computer teachers that are in the group, you might know that whenever we write a program in Turbo C, it runs on the PC itself. But in this case, the code will not run on the PC. You can compile it here. Here you can compile it, but it will not run on the PC. You will need to upload this code to a board. Okay, you need to upload this code onto some Arduino board. Okay, so as I told you earlier, we will be seeing like virtually how can we program the Arduino. I mean, you can create a virtual Arduino and program it. All right. There is a software called Tinkercad. It is made by Autodesk. Okay. So in this software, you need to create an account first, or you can sign in with your Google account. Okay, here you can actually create other 3D designs as well, but we will go to circuits and we will go to create new circuit. Okay, so here are all of the components. These are the components. I hope it is clear. This is the resistor, LED, push button, potentiometers, capacitor, switches, batteries, and here we have the Arduino itself. Okay, so I will actually show you a very basic example. Like we take an LED, we take a switch, and we take a battery. Okay, and we wire the whole thing up. How to wire? You just need to connect it like this. And then we run simulation. And when we switch on the light, okay, it must be connected in reverse. Here, actually the 9-volt battery is too much for the LED, but you can see when we slide the switch here, it is showing that it will glow. Okay, actually we in robotics, as per the fundamentals, we should use a current limiting resistor so that the LED does not blow up. So we'll add a resistor, ignite it. You can even assign the values for the components. We click on the resistor here and you can increase the resistance or decrease the resistance here. And then currently it is 1 kilo ohm, so I think it should be good enough. Then we start the simulation and now you can see when I press the slide the switch, the LED is glowing and switching off. So you can see that this is a virtual platform on which you can actually run your experiments without any hardware. You don't need to purchase any hardware. This is completely free of cost, and you can implement whatever you want to do on the software itself. You will not damage components. There is no cost involved. So it is an excellent software. And most of the times, I have personally used this software for teaching the students, like for when I'm conducting robotics webinars and all, for very young kids. I have used the software and it is excellent in teaching. You can use it for your own learning experience as well. You start on it, and as you progress, then we can switch on to very complex softwares like Proteus. There are other softwares as well. When you get into the field, you will automatically come to know about different softwares. You don't need me to tell you that those are the softwares. Because by the time you are expert in it, you will know what to go for, what to choose. It will take you some time, but you can do it. So, uh, since this workshop is not about how to, not a workshop on how to do robotics, it is more about the overview. I'll show you like how you can actually program an Arduino on the virtual level. Okay, so we have the Arduino here. Yes, someone. From Divya K. We should download this from Arduino website. Yeah, the IDE that I showed you earlier, Arduino IDE, that you need to download it from the Arduino website. But this
Okay.
Arduino,
Okay. My question was about that only, sir.
okay.
Yeah.
For from A. Sindhuja, sir, is Tinkercad available for dealing 3D object? Yes, you can make 3D objects on Tinkercad as well, but that is not the scope of this video. So I'll be dealing with only the circuit parts. Yes, you can use the Tinkercad for 3D designing as well. So if we go back to the sketch, this is a very basic sketch. What this program does from here till here, this blinks an LED on and off. Okay, it blinks the onboard LED. There is an LED on the Arduino itself. This L, it is denominated as L. Actually, it is connected to pin number 13. This pin number 13. Okay, it is internally connected here. So you can blink the LED on board. Okay, so this is the software here. I mean the small code. We will copy it from here. Okay, actually you can write your own code as well, but for time's sake, we'll copy it from here, and then we'll go to code. We'll select text. Oh, this code is already here. We'll paste our own code. Okay. See, the LED built in here is actually pin. We should write it as pin number 13. Actually, don't worry about how these things are working. Just I'm giving an overview as to how to go about, like the basic introduction, the programming and all those different things that you will have to learn on your own. You'll have to take up some course, but that part you will have to take care of yourself. Okay, so once you have written the code, then you can start simulation. Okay. Okay. So here you can see this LED is blinking. I hope it is visible to everyone. There is one small LED that is blinking, so it is indicative of the fact that our code is working. Okay, you can write any other codes once you become an expert on how to go about programming and all, you can write several different ones. See, this is not for very advanced programming. Complicated programs might not work on this platform. I mean, on the Tinkercad itself. For that, you will need to use the Arduino Ide along with an actual board. Okay. Any doubts still here? Any queries?
No, sir.
Okay, so there are, before you actually go and start with the, with the Arduino itself, what I recommend you is to, whether you learn yourself or you teach kids, teach the students, that you go for the basics. Here you can see the most important law in any electrical engineering or electronics is the Ohm's law. Unless you are very familiar with the Ohm's law, you cannot progress with working with different components, because every electronic component has a voltage and a current rating along with an internal resistance. So you need to be aware with the laws of electronics so that you can progress properly with robotics. Okay, so like I just showed you, like you cannot connect an LED to directly to a 9-volt battery, because the 9 volt is too much for the LED. Okay, the only way you can connect it is by using a resistor in series, so that the resistor will drop some voltage across it. All right, so these are the fundamentals that should be clear before progressing with the Arduino portion. You need to be very clear in yourself, as well as the students which you are attempting to teach robotics must be clear with the electronics portion. Once you have gone through all of this, uh, like the basic items, actually there are a lot of other complicated features, sorry, I mean complicated sensors and tools available. This is the basic selection. If you go to all of the components, there are a lot of it that you can actually utilize uh, for the that actually works with the simulation on this platform. There are these ultrasonic sensors and other IR sensors as well, and even oscilloscopes. Okay, so the proper approach that I'm repeating, like the proper approach for progressing with the progressing with a robotics module to teach the students will be the fundamentals and laws of electricity, like the Ohm's law. There are some other laws, the Kirchhoff's law. Those are not very very much required, but they should be kind of taught to the students. And then the properties of different components, such as resistors, LEDs, potentiometers, and such. All of the electric components, properties of the basic electronic components should be clear to the students. That once they are clear with that, then they should be able to create basic circuits using those components, keeping in mind the laws of electricity. That means the voltage and current ratings of the component should always be in accordance with the ratings of the components. I mean, they should not overvolt or overcurrent a particular component to prevent damage and all. So these factors should be clear before progressing with the programming. Programming should actually come at last. Once they are done with the basic analog circuits, then you need to progress to the programming portion. Again, in programming portion, the basics of the programming should be clear. You straight away should not go to the complex codes. They should be clear with the fundamentals, the syntax of the codes, like what are keywords, what are identifiers, what are functions, different control loop, if statement, if else. All of these control loops, they should be clear with all of the fundamentals. And then once they are done, you can integrate this programming skill with the knowledge of electronics. That becomes your robotics. Okay, so this should be a proper approach to learning robotics so that the foundation is strong. Unless there is a strong foundation, you cannot progress with the coding in future. Like you will hit a bottleneck. There will be a limitation. Again, the students don't who follow this strategy properly, they will actually have to revisit the topics later on at some point of time to go through them again. Okay, the basic foundation is very important while attempting to learn robotics. And again, as I have said, this is going to be the most vivid topic in recent times. Like your cell phone is a robot. There are displays and there are what small haptic motors, small speakers. Your touch screen is a capacitor kind of thing. It is based on capacitive response. So all of the fundamentals of the robotics are usually converted into much higher level engineering, and then they are converted into products. So these technical education will provide a broader way or a broader scope for the students in the future. Alright, any queries from the participants side? Like I know there will not be much doubts because the whole concept is kind of new, I guess. But if you are curious about anything, like how it works or something,
All clear, sir.
Sir, how to put audio commands, and depending on our audio, it will switch on and off the LED.
Okay. You want to command LED with an audio. Yeah, Mr. Vijay Kumar Singh, please show some circuits using this software. Alright, I'll show some. I just showed one circuit, but I'll show a few more. Okay. Actually, there are lots of methods that you can use to command, like the Google Alexa, Amazon Alexa, you might be aware of, or the Siri or Google Assistant. You can integrate your robotic softwares projects with these high performance, what you can say, virtual assistants, right? You tell your Alexa that you need to switch off your fan or switch on your light, and it will do it for you. So those kind of robotics is called IoT, Internet of Things. Okay, so how it works, when you command Alexa, turn off the lights, so it has been trained using an artificial intelligence module. Lots of sounds. Even if you do not speak very clearly, it will still understand that the master is saying me to turn on or off the light, turn off the light. So in artificial intelligence or machine learning, you train a program using repetitions, using slight variations and repetitions, so that it knows that even if there is a slight difference on the sound, I mean the voice, it will still recognize that recognize the command. Okay, so you tell the Alexa that switch on the light, so it will convert that, it will go through a menu. Okay, this is the switch on the lights, and then as I told you, you need to have hardware side as well. You need to integrate your project into the Google Alexa, or you can buy ready-made projects as well. So that integrates, and see, I just told you here. Actually, I cannot show you the switching of the light using voice on this platform. This platform is not capable enough. It does not have those features like voice recognition all. But there are special voice recognition sensors. Okay. You see, voice recognition module for Arduino. Okay, this kind of voice recognition modules, you can purchase them and then you integrate them with the Arduino. Okay, you connect them up to the Arduino and you write the code on that. Okay, but that module is actually not available in the software. So I will not be able to show you how to command it with the voice, but the concept is the same. You say a command, the Arduino will process the command, it will process the command as to what you are saying. There will be a list of commands. Okay, switch on light, switch off light, increase the speed of fan, decrease the speed of fan. There will be a list of commands that will feed the Arduino into, and then it will match which command is that you have given, and it will match, and then it will execute the command. Okay, here I will show you by connecting a motor. Okay, so this is a DC motor, very simple DC motor. Okay, if you have studied electronics, you know that the DC motor requires some power, some energy, but the Arduino cannot directly provide so much energy. Actually, this is the IC semiconductor. This is the IC, and if you go through the data sheet, actually every semiconductor that is available in the market, any IC integrated circuit, this is an IC, this is an IC, this is an IC, any integrated circuit, it has a product manual, it has a data sheet. The model number for this IC is Atmega 328. Okay, so here we go at and search Atmega 328P data sheet. Okay, so you will get a kind of a manual, but it is a very large manual. Okay, it approximately, this one has 294 pages. So you go through it and you will find every information about how to program it, how to do, how to use it. But I said earlier, this was the problem. This was the actual problem. When you go and refer this data sheet, you will realize that it is not simple, not easy for a general person, a beginner or a noob to actually be able to program it, because the codes that are being shown here, they are shown in assembly language. I will show you. Yeah, you see here are some examples being given, but these are all assembly or its proprietary language, that is the AVR. Here it is in C language, but it is actually its proprietary AVR language, and this is not something that is easy to understand. See, there are, it is the example code is given in assembly language. It is given in C language also, but this is again very proprietary to this particular architecture or this particular chip. You cannot use, even if you learn this language, you will be limited to programming kind of only one microcontroller. If tomorrow you want to switch to a different microcontroller, you will have to learn the programming language that has been designed for that microcontroller. This is again a challenge. In Arduino, you can learn and use one single language to program different kind of processors, different kind of microcontrollers. Okay, actually, we were here to see how much current does it can supply. Okay, so it might be difficult from the data sheet to find out. We can just search on the internet itself. You see, the GPIO, general purpose input output. Actually, the term sounds complicated, but it is referred to one pin of the Arduino. The general purpose GPIO pins cannot supply combined of 200 milliamps. So we are assuming approximately 20 milliamps per pin. Okay, one single pin can output only. You see, these pins are connected internally from here all the way to the microcontroller through the PCB. Okay, and it cannot deliver more than 20 milliamps. So you cannot directly run a motor. So we'll use a transistor in low side as a low side switch. Okay, bear with me. This sounds a little complicated, and I know that not all of us will be able to understand, but I'm just trying to prove the point and provide a proof of concept, like how you can actually implement the circuits in the software. Okay, so we are using a MOSFET. It is a switch. Okay, it in simple terms, you should just understand that this is a switch, but this is not a mechanical switch. This is an electronic switch. There are no moving parts in it. Okay, and it can handle a lot of current. That's all we need to know for as of now. Okay, so there is the gate. We also need a battery. Okay, so basically what we have done here, we are using a motor, a switch, and a push button. So what we will do, we will write a code that when somebody pushes this button, this small button, the microcontroller will switch this MOSFET on. Okay, I mean it's kind of a switch, but there are three terminals. That is, one terminal is there to switch this entire thing on and off, and there is one. Let's say it is input and one is the output. Okay, so what will happen, what we want to happen is that we press the switch and this motor should spin. Okay, so we will actually, even when we are writing a code for this on this Tinkercad, to write over here is not a very good idea, because there is no what to say, color indication. Even if you are writing something wrong, it will not tell you. You should practice writing the code on the IDE itself, because here everything is color coded. So if you are writing something wrong, you can see that okay, I'm doing something wrong, and so you can rectify yourself. Yes, someone had some doubt. Okay, just to save time, we'll use some pre-written code and we'll modify it according to our requirements. So here is a push button base code. So our push button is connected to, we'll go check here. Our push button is connected to pin number 3. Okay, so we'll make the change here, push button, pin number 3. And this one we will declare it as motor. And it is connected to pin number 7. Okay, end button state 0. Real light. Okay, again, there are rules that you need to follow while writing such a code. This is where you declare everything. And if you have used C++, you will know there is a void main and void loop. Sorry, there is only a void main where we set up the entire code, and then we, I believe, we write a loop. We declare a while loop inside which the entire program keeps on running. But to simplify the matter here, there is a void setup here, and there is different loop, that is void loop, and these loops they pre-exist. Okay, this is the syntax that you will need to follow in this case. This is just for simplification. Otherwise, you can delete this void loop entirely and just practice whatever you learned while programming C or C++. You can program it exactly the same way as well. Okay, so our motor is an output. Okay, it is an output device, and our push button is an input device. So we are declaring. See, it is very simple. If anybody has programmed an 8051 using Atmel Studio, that is the proprietary programming language for the Atmega 328P microcontroller that is present on the Arduino. Okay, the proprietary language is AVR. If anyone amongst you have used, you know, in order to set up a pin, you need to declare the data direction register, data port register, and then pin register, so that you tell the compiler whether this pin is an input output pin, and then where it belongs, the address, that is the data port register, etc. to set up the pin. Here we can just write pin mode. See, this is the encapsulation and the abstraction that I was talking about. A very long piece of code has been shortened into a very small form factor. Okay. Once you have set up both the input output devices, then this is the loop portion, that this is the portion that will keep on executing repeatedly until you switch off the microcontroller. Okay. So here we are doing button, like we are trying to read the button. Okay, so this is digital read button pin. Okay, if button state is high, like that means nothing is connected to the button, then the motor should turn off, and when we push the button it should turn on. Okay, so that's what we want. Okay, so it has successfully compiled the program. Okay, so we will just copy this program. And I'll paste it over here. We need to make a very small change to the circuit. Let's see if it runs. Okay, so the simulation has started. Okay, here you can see what I have done. I'll explain the code once again. There are two components that we need to take care of. That is the motor, and this is the push button. So we have created two subjects. Okay, two constants. That is the button pin, or you can. This is an uh, again. I don't want to go into a lot of details on how to learn programming, but these are called keywords. You can declare it as per your choice. Keywords identifiers as such. Okay, so these are the keywords. You can declare it anything. I have here it was already declared as a button pin, so I have left it as it was. And see, the button is connected to pin number 3, D3. So here I have declared it as it is connected to D3. If it was connected to, suppose, let's say 4, let's say it was connected to 4, then all we need to, oh, sorry. Then all you need to do is write it, declare it as pin 4. Okay. Similarly, here the motor is connected. It is not, the motor is not directly connected to pin number 7, but pin number 7 is responsible for turning on the switch, and thereby actually see how this circuit is actually working. From here the electricity is coming into the motor, but this switch is turned off unless it has some kind of voltage. It does not operate. Okay, so that voltage is actually provided by the Arduino. So as soon as this voltage is here, this current can pass through this switch into the negative terminal of the battery. Okay, this is just very basic. You just need to understand how to like use the components as per the code. Okay, so in the code we have declared motor and button, and then this is an initialization. Just skip it for the time being. Here we have set up what are our declarations mean. That is, motor is an output device, our push button is an input device, and then here is the actual code that is running. This code is checking if our push button is uh, again, this is a little bit tricky to try to make you understand, because there are some fundamentals that actually one should understand before going through all of this. See what will happen. This pin number 4 will connect through this switch into the ground. Okay, and ground in in language of electronics, in language of robotics, ground is called as zero or low, right? Computer understands only two things, on or off, one or zero. This is the only thing the computer actually understands. Everything, every code that we write will actually end up as ones and zeros. The compiler will compile the code, it will convert everything finally into ones and zeros and feed it to the microcontroller. Okay. So this is how programs are written. If we push this button, this pin number 4 will connect to ground. Okay, so this is what we are writing. If push button equals to low, okay, I mean if the button is connected to ground, okay, so if else, right, if yeah, if this is happening, then switch on the motor, okay, otherwise keep the motor turned off. Okay, let's run the simulation and see again. Okay, when I press the button, the motor starts to spin. You see, as soon as I let go of the button, the motor stops. So we can verify that the code that we have just developed is working and is fine. Actually, you can use a lot of very complex components. There are a lot of things available over here, but to show them in this video it will be kind of meaningless because we need to actually have the knowledge of how to use the components in the first place. Okay, so I think this is clear, and to some extent it shows that you can use almost any kind of component, not any kind of, like most of the components that you will actually come across even in real life uh, to progress about with robotics. Those components can be used on the software without any cost. Okay, like if in real life if you go and find all of these components, this will right now as it sits, these 4 or 5 components will cost you more than 500-600 rupees. So you don't need to actually go and buy the components. You can practically do it here itself for absolutely free. Right? There are, if senior professors are in the group, they will know, like there are oscilloscopes used in the labs. Okay, even we have oscilloscopes here. Okay, this is a very expensive piece of equipment. We even have function generators here. Okay, these are worth tens of thousands of rupees. Sometimes they run into lakhs. I know that you cannot use them for very complicated tasks in these on this software, but you can see do and see a lot of things here. Like if you want to probe a signal, you feed the lines here itself, and you can see the signal, like what signal it is outputting, the microcontroller is outputting. You can see the signal here itself, and we have multimeters as well for testing. You see, most of the components, expensive lab components, are also available on the software itself. So this is a great. This is very encouraging actually. If you teach someone, you don't who is scared, and like not everyone has the financial capability to go ahead and purchase expensive components for the sake of learning robotics in the very beginning, or some just don't want to. In those cases, this is a very great encouragement. This will be very encouraging for students, so that they don't have to spend any money, and they can just use the virtual program. Most of the basic programs uses breadboards. This is actually a bit bigger. Okay, such breadboards in practical practical sense also, these breadboards are being used in robotics labs for teaching purposes. These components are available here as well. On this, you can mount different type of components, right? You can mount different type of components. You make the circuits without having to risk anything, and you can go from there. Once you're comfortable with all of this, all of the virtual stuff, you can definitely move on to more of the hardware stuff, more of the practical stuff. All right. Any doubt with anyone till here? I'm sure there will be a few doubts. Like there should be a few doubts because this is a lot to take in actually. So no doubts till here. Why resistor is connected in Mosfet switch? Okay, this is a bit complex. I will show you why I have connected the resistor from Jithin Lawrence. Okay, let's remove the resistor and see. Okay, I have removed the resistor and let's see what happens. Yeah, here it is actually performing properly, but in practical reality, if you remove this gate to source resistor, the MOSFET will not turn off actually. The capacitance that builds up on the gate, it keeps the MOSFET switched on until the capacitance, the charge is drawn into the source. Actually, this is the problem with these basic simulation softwares. They will not tell you everything. This feature, if you simulate in on a paid or an expensive software, simulation software, then you will see that if you do not have a gate register connected to source, as soon as you remove this pin number 7, this charge will actually remain on the. Okay, this can be actually probably better shown. Okay, yeah, that will not be possible. So that is like I am habitual to designing circuit boards. So it is in my practice to connect. Actually, I should connect a gate resistor in series to the pin number 7 also, but I have skipped it for the just for demo purposes. But I was thinking that if I do not connect the resistor from gate to source, the MOSFET will not turn off even if I let go of the switch. That's why I connected it in. Connected to the source. I hope I have answered your question. Any other doubts, Hillier? So have you understood like how to find? Now I'm hoping that you have a clear vision or view about how to get into the robotics. It's pretty simple. Once you go with begin with this stuff, slowly you can go ahead and try the complicated robotics things as well in the future. But I suggest that you go in a very systematic manner if you want to pursue it as a career or you want to excel in it in the future. Because this is a very huge subject actually. It is a culmination of all of the disciplines of robotic engineering. You need programming skills, you need electronic skills, you need mechanical skills in order to make a robot. And robots, you have seen like there are millions of dollars worth of robots, especially in these factories which do this automatic welding and sorting and stuff. So the main cost is due to their precision in which they work. It is the mechanical aspect of the robot that is kind of very expensive. Also, the sensors that are being used in the uh, robot in order to sense its surroundings, those sensors are also very expensive. So you should have like proper knowledge so that you can implement them very correctly in order to make the project. Okay, any other queries that you might have from the entire session?
Hello, sir.
Yes,
Hello.
yes, please.
Sir, can you explain about ultrasonic sensor?
Okay, I will try to explain.
Yes, sir.
Okay, actually, see this webinar is about you introducing you to the field of robotics, but in order to learn about all of the sensors, you need to have put in your own work. But here I will just very briefly define because this is a very interesting sensor, and I actually get a lot of queries or because this is very popular and everyone use it. Okay, so I will
Yes.
start with the basic fundamental, like what it does. Okay, so and you will again get to appreciate how powerful actually nowadays computers are. You see, what it does actually, this is the VCCN ground. That means we need to provide 5 volts at VCC and negative at the ground. So this is the power supply, and this is the trig, and this is the echo. What happens when you give the trig pin a pulse? Okay, when you give the trig pin an on signal using the microcontroller, there
Yes.
it will emit an ultrasonic sound from this trigger. You see T, here it is written T, transmitter. Okay, this will emit an ultrasonic sound, and that ultrasonic sound will that is emitted will, if there is an object in front of that transmitter, then the ultrasonic sound will come and reflect on the from that object and will be received by the receiver. Okay, and at that time it will generate an output. Yes, I have received an sound. Okay, and
Okay.
okay, so what the microcontroller does is that it measures the time. You see how fast it is. It measures the time from the trigger, from when it has given the signal to the time taken to the to the sound that is been received. Okay, it will measure the time between these two. Okay, and then it will calculate the distance based on the time taken to receive the signal. Okay, so this is the basic function. This method is, see, sound is quite slow. It is still very fast. I know, like 1,000 kilometers per hour, but it is still slow compared to light. Light is like 3 lakh kilometers per second, but
Yes, sir.
but believe me, the lidar modules, Tesla, a lot of automatic driving systems, self-navigation robots, they use LiDAR, laser-based sensor. Okay, LiDAR is means it is kind of a radar that is based on laser, right?
Okay, sir.
Now the thing with laser is that it emits laser light, right? It goes to it bounces off a surface and comes back, and the time taken from the emission of the laser to the receiving of the laser, the time is measured and the distance is calculated as per the time taken. So you can imagine how fast these microcontrollers are actually, that it can measure such small, very small nanoseconds, and it can measure those times. Okay. And again, this might be looking very complicated, like how to use this ultrasonic. Yes, it is complicated. If you go by the conventional means, it will be an complicated item to be integrated with a microcontroller. But let me show you. You go to Arduino Ide, okay, and what you do, uh, you use include library, and you go to, I don't know if I've installed this library. Yes, ultrasonic. Okay. Actually,
Yes.
you can install these libraries, right? Ultrasonic. And I'll even show you an example based on ultrasonic. Okay, this is actually the HCSR04. You see here the model number is HCSR04. Okay, right?
Yes, sir.
So you see, you include the library, you set up, this is the just the serial begin, this is the to set up the serial monitor, we don't need to discuss here. And you see, we are just displaying the distance on the serial monitor. Serial monitor is, you can click here. Actually, I don't have an Arduino plugged into the computer as of now. Otherwise, you can, if you open the serial monitor here, you can see like what is going on the Arduino. You can communicate with your computer through the Arduino, right?
Yes,
Like
sir.
this particular example, what it would have done, it would have displayed, suppose for this example, you would have connected your Arduino and you would have connected an ultrasonic sensor to the Arduino, and then you would have uploaded this code to your Arduino, and the Arduino would have returned you the distance measured. You point the ultrasonic sensor towards any object and it will tell you the distance, and it will display the distance on this serial monitor. Okay, on a small kind of window would have opened here if I had any microcontroller plugged in. Okay,
Okay, sir.
okay, so it is very simple. You see here, you have just called this function, distance sensor dot measurement cm. That's it, you get the
Yes.
value. Okay, this is the simplicity that we are trying to address here.
Okay, sir.
Right, you don't need to go through all of the complex mathematical calculations and derive what how much time passed while the signal was sent out. Everything will be available inside a library like this. Okay, you just need to search. You see HCSR04 library. You just need to search this library and you
Yes.
can just download it. And there are videos on how to download it and add it, include it into your Arduino code. There are videos on that. You can follow the videos. And it is very simple. That way you can use lot of very complex sensors and different peripherals with your Arduino. Not only this sensor, but lot of them.
Right, sir. Thank you, sir. Thank you, sir.
Yes. Here are other sensors like this EIR. This is like motion detection used for motion detection. Like if there is any movement, this sensor will output a voltage. Okay. For again using these sensors, you can just use the library. You can utilize it with your code. Very simple. Okay. Any other doubts? Okay, so basically this is it. This is all that you should be aware of while starting with robotics, as far as I believe. And this is the most simplest way. I don't think there is any other way that you can actually start with robotics without having spent a single rupee from your bedroom. Like you're sitting and just you can implement these. And if you get comfortable, that obviously you can proceed with the hardware portion. You can purchase hardware and use it. And as you might be aware that a lot of IITs and NITs, they organize technical festivals across the country for such robotics events, and there are challenges that are being given to the students or tasks that the students need to fulfill, and the whatever the criteria for winning there is. So it is a very interesting subject, and a subject which is, you see, usually the subjects which are very interesting, uh, they're very difficult to approach, right? I mean, they're kind of difficult, but this is one topic which I personally think is very interesting as well as very easy to approach as well. You can start with very simple logics, very simple components, and work your way up to some very complex topics as well. Okay, so I have, like, from my side, I believe this is all that I have to present to you, and you have been a very wonderful audience so far, and I enjoyed a lot interacting with you. And if you have any queries, I think we still have like 10 minutes before we wrap up. And also, if someone actually want to get into setting up of labs for schools and other purposes, for educational purposes, they can email me and I should be able to help them out. Okay. Yeah, all of the, yes, welcome all of you, and thanks a lot to you for giving me this opportunity. Again, I would like to thank Mr. Professor Pankaj Madan, Dean, Faculty of Engineering and Technology, Gurukula Kangri Vishwavidyalaya, and Mr. Gajendra Singh Rawal, Assistant Professor in charge of Electrical Engineering Department, Faculty of Engineering Technology. I thank you once again for giving me this wonderful opportunity, and I hope that I'll be given chances like this so that I can share my experience and knowledge about the subject.
Hello. Hello.
Yes, sir.
Hello. Hello.
Yes, ma'am. Session is over.
Okay, so thank you so much, sir, for such a wonderful session. And now we are having a test, which is going to be start at 3:30 p.m. So, link of the session will, of the quiz will be shared soon. So stay tuned.